An earthquake of historic proportions strikes Japan. The massive 8.9 magnitude quake tears its way through houses, businesses, and densely populated neighborhoods. Video captures the scenes of devastation. Minutes later, a tsunami follows, slamming the northeast coast. The Sendai airport is awash in the tsunami wave, with people scurrying to the rooftop for safety. The tsunami races across the Pacific, traveling at 500 miles per hour. Hawaii braces for impact, sending people to higher ground. Though the swell is just 3 feet, there is concern that the tsunami will build when it hits the west coast of the U.S. Residents from Seattle to San Diego are on alert. In Japan, the quake's toll is reported to be thousands dead. It causes little damage in the U.S., but scientists warn that another megaquake is building, at least as powerful and much closer to home. The next tsunami to hit the shores of Japan may begin with a megaquake right off the American coast.
It's going to blow people's minds.
It will be a disaster, much larger than Katrina.
You're talking about something that's tens of thousands of times the size of any earthquake we've seen.
Now the race is on to predict when it will hit.
I wouldn't be surprised if it happened next week.
And just how powerful the wave of destruction will be. The Japanese earthquake is the largest ever recorded in Japan. But over the past decade, equally devastating quakes have struck around the globe. Megaquakes are among the most powerful forces of nature. They rival the destructive energy packed in an arsenal of atomic bombs. And they strike suddenly, violently, and without warning. In 2004, a megaquake in Sumatra triggered a monster wave that killed more than 250,000 people. In 2010, another strike, this time in Chile. This megaquake had the power of thousands of nuclear bombs. It sped up the Earth's rotation, shortened the day by a microsecond, and moved an entire town 10 feet. Now, many investigators suspect that the U.S. could be next, and that the Pacific Northwest is in the same crosshairs. 3 large cities: Vancouver, British Columbia, Seattle, Washington, and Portland, Oregon, as well as 10 million people, sit right in the danger zone.
As far as fatalities, it would be on par with what we saw in World War II. We would expect to have 2, 3, 4 people per 1,000 die. It's the same type of earthquake that we saw recently in Chile, which was a magnitude 8.8, and it's the same type of earthquake that we saw in Sumatra in 2004. That was a magnitude 9.1.
Investigators believe the threat of a similar megaquake is real. Just offshore, hidden beneath ocean waves, lies a ticking time bomb.
This is the spot where the earthquake's going to come from. It's about 12 to 15 kilometers beneath the seafloor right below us here.
Marine geologist Chris Goldfinger gets as close as humanly possible to the place where the Earth will start to rip apart. A megaquake strike zone. We like to think the Earth beneath our feet is solid. But take a closer look. The crust is actually made of about a dozen plates. They move, grow, and grind into one another along fault lines. This is where megaquakes are born. In Cascadia, a Pacific plate named Juan de Fuca meets North America and dives below it. It's a special fault called a subduction zone. A megaquake is fueled when the two plates get stuck, pressure builds, and then breaks free with fury. Investigators can't look into the Earth and watch the plates, but their high-tech tools paint a picture of an impending disaster. A submarine camera captures the point where the two plates make contact, about 60 miles off the coast. The video reveals little sign of trouble. But Goldfinger sees enormous and dangerous forces at work.
Okay, we're going to put the pole out.
Sonar detects what's invisible to a camera's lens.
Yeah, okay. About where that 20,000 mark is?
Yeah, that'd be perfect.
If the fault is harmless, the seabed should appear smooth and undisturbed. This would indicate the plates are slipping past each other unimpeded. If sonar detects mountains, it's a sign the plates are jammed and an earthquake is building. The sonar map is striking. The Juan de Fuca plate is jamming itself under North America, pushing up the continental shelf. The two plates are not sliding past each other. They are locked in a collision. North America is buckling under pressure from the oceanic plate. And at some point, it will suddenly release in one massive jolt.
A subduction earthquake is the largest type of earthquake on Earth, and the reason is that the size of the earthquake is proportional to the surface area that actually moves during the earthquake.
That surface area is huge. It is some 600 miles long, from southern Canada to northern California, and at least 30 miles wide, making it as big as Ireland.
The surface area is just giant. Very large surface area makes a very large earthquake.
The fault is so large, scientists give it a special name: a megathrust. And while they've struck before, none has ever threatened an area as highly developed as Cascadia.
In recent times, there has not been a megathrust earthquake under a major city. So we really haven't seen the worst that the Earth can throw at a major city yet.
Due to the fault's size, the tremendous shaking could last for 5 minutes. A virtual lifetime of terror for those who experience it.
One thing that's dramatically different about these big subduction zone earthquakes is that they take a lot longer to rupture because they rupture a large area.
The threat is looming, and that poses a terrifying question. When will the megathrust ultimately strike? Geologists Rob Witter and Tim Walsh are looking for clues. This long-dead stand of trees is known as a ghost forest. And this ghost forest has a story to tell.
This is a fossil forest, and like the forest behind us here, it was a healthy, vibrant forest full of western red cedar and Sitka spruce.
Investigators suspect a mammoth earthquake sank the land. The tide invaded and created a swamp, killing the trees.
Once this forest was submerged, it couldn't live with the salt water, and slowly the trees began to die off.
Carbon dating shows the ghost forest died around 1700. But the definitive date is corroborated by another event, half a world away, in Japan. And it also involved a flood. The recent Japanese tsunami was not the first to hit the Japanese coastline. From out of nowhere, massive waves slammed ashore. The date was January 27th, 1700, about when the trees in Cascadia died.
That pointed a finger directly at Cascadia as being the source of that tsunami.
The puzzle came together. In January of 1700, a massive earthquake hit, sank the coast, flooding forests. And just as today's Japanese earthquake started a tsunami that quickly reached American shores, the Cascadia quake also generated a tsunami, powerful enough to swamp unsuspecting villagers thousands of miles away.
It must have been an earthquake on the order of about a 9 to 9.1. In other words, it had to have ruptured the entire Cascadia subduction zone from one end to the other. And that's a distance of about 600 miles.